Okay, so for example 6, you have a rectangular P patch. Okay, it's been enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. So drawing's gonna be a little strange. They have a rectangular patch. It's like a rectangular garden bed, if you want to think of it that way. But it's gonna be divided into 2 equal parts. So how else am I gonna modify this drawing? Yeah, Prolines Method in the middle, right? And so it's parallel to one of the sides. So what are the dimensions for the outer rectangle that require the smallest total length of fence? So basically we want to minimize perimeter again. Let's say call this X, X, X. Let's say I call this whole thing here Y. And that whole thing there Y. What's going on? Go ahead. So, how am I going to write the perimeter now? No, 3x plus 2y. Right, but the thing is that we don't know how much total fencing to use, right? I know it's a little tricky. I know. I should have been careful how I wrote that, but yeah, exactly. So see how I need obviously use some fencing over here as well as on the perimeter. Yeah, I probably should have done a different letter or said something else, but in the area is still what? XY, exactly. So 216 equals XY, or you can say Y equals 216 over X. That's 6. So its perimeter is 3x. So that's the perimeter. Again, we have you guys work this out on your own. So go and work this out and tell me what you get. You might want to use a calculator for this one too. 432. Or 32. 0 to infinity. Yeah, because your x could be, or your y could be as long as you want. But then, of course, you compensate by making the other one as small as possible. Or super small. So 2/16 is just your area. Right, so it's inverse relation. So yeah, basically, like, I mean, you can make x as large as you want, then y would be super small, right? You guys arrive at an answer yet? Yeah, 12 by 18. So yeah. So exactly. Yeah, so domains from 0 to infinity, so still an open interval. Here's our perimeter, or whatever you want to call it, the total amount of fence used. Substitute. We take the derivative. You get negative 432x negative 2. Solve for x squared. You get 144 x equals 12. When you do a sign chart, I try 11 and 13, one to the left, one to the right. 11 squared is 121. 432 or 121 is like 3 point something. So that results in a negative derivative. If you put in 13, it's 169. 432 or 169 is 2 point something. So it results in a positive derivative. It's just going down, then up. So that way you know for sure that gives you a local min. Well, that just proves that your critical point here provides a minimum value. That's all. That's what it's proving. Because you got to be able to prove it. Okay, so we're okay with that. 12 by 18. All right, let's try one more, and then you guys can look at your final exam.
Is mine?
Yeah, sorry. And you're Thompson. Okay, so you have to ask him for it. Okay, example 7. You have to design a closed top cylindrical can that will hold 1 liter of liquid using sheet metal. What dimensions will use the least amount of metal? Okay. So we need two formulas. We need the volume and the surface area. Volume I think might be kind of easy. Surface area, what? Well, most cylinders are usually right angle, but you could have one that's not right. Oh yeah, cans should be circular, but they could also be oval too.
No, I create like between like I just
Yeah.
know what could be meant.
Basically, the altitude. Yeah, so you got it. All right. So volume. You guys remember volume? Pi r squared h, right? And here's a picture. There's h. There's r. Pretty easy, right? SA stands for surface area. Does anyone remember what this one is? You jog your memory from 3 years ago.
Surface area is the height times the circumference, which is height times pi times diameter.
What is it?
It's the pi times diameter times height.
That would be the lateral area.
And then plus pi r squared times
Good. So here's the thing. You need 2 pi r squared because you have two circles, right? Top and bottom. So, I mean, obviously it's not a perfect cylinder, but you have this and up top. And then the lateral area basically takes the circumference into account, which is 2 pi r times the height. I wouldn't mind giving this to you on a test, but I don't think the AP would. So you probably would need to know that. Or store in your calculator. So 2 pi r squared plus 2 pi r h. Because a problem like this will require a calculator because the numbers come out pretty ugly. Now we want to Now, they didn't explicitly say to minimize surface area. They didn't specifically say to minimize surface area, but you want to use the least amount of material, right? So you want as low area as possible. But the volume has to stay fixed at 1 liter. Now, this is tricky because the units are weird. Because usually we're dealing with like millimeters or centimeters or inches or feet or whatever. If you think about 1 liter equals how many milliliters? Okay, and the reason why I'm doing that, oh good. Oh, how do you know that? You just remember? Oh good, okay. Yeah, 1 milliliter is 1 cubic centimeter. Or we say 1 liter, 1,000 cubic centimeters. So we can use that for over here. And what do you think would be easier to isolate? R, H? H, yeah, so we don't have to deal with any square roots for now. So now we can rewrite the surface area. So now we can rewrite the surface area, knowing what H is. And so it's all in terms of one variable. Clean it up before we take derivative. So how would the right side of the plus sign be cleaned up? What can go away? So the pi's could cancel. Good. So it's 2,000 over r. Or, just to make the derivation part easy, let's rewrite as 2,000 r negative 1. So okay with all this so far? Right? Taking derivative shouldn't be too bad. And leave everything in terms of pi. Don't substitute 3.14. We'll compute everything all at once. We actually have to make the calculations. So surface area prime will be 4 pi r minus 2,000 r to the negative 2 power. And of course we substitute 0 for the derivative. Minus 2,000 over r squared. So you kind of have to do some fancy algebra, like move maybe the fraction over, cross multiply. I'm going to have you guys calculate this on your own. Tell me what you get for r. This is the algebra where you guys should have this down cold, but sometimes you guys could be a little careless, so tell me what you get for r. I'll give you guys a minute or two. You will have to cube root as well. So we get an answer? Wait, what? Yeah. Yeah, thank you. I don't know. Well,
You get R equals cube root of 2000 divided by 4 pi. Yeah. What's wrong with my calculator?
wait. R cube equals what?
I got R cubic is 2000 divided by 4 pi.
Okay, good.
And then I just did.
Oh, did you put parentheses around 4 pi?
No.
That's why. Yeah, that's why. Yeah, why are you talking about like War of the Ring characters? Yeah, I can see that. You're just absolutely dressed ridiculously right now too. So, I know you're doing kids, so I get it.
No, it's like not even that. I don't know. The last period was really like one go very nervous with it. No, I just I just can't. I don't want to sit here anymore.
We're almost done. Relax. Okay. Goodness. I know we're almost there. We're almost there. Okay, thank you. All right. Okay. And then when you solve for h.
No, you were trying it. You were trying it.
By the way, this is all being recorded right now, just so you know, for Charlotte. So she's hearing all these crazy stuff. So. Just so you know. Probably.
Okay, well, it doesn't matter.
How come you not wearing your World of Warcraft headphones?
First of all, I don't play World of Warcraft. And second, my headphones are at home. So. And it looks... I don't want to look as ridiculous as you, that's why.
But freshman year, when you would go on iChat for us, one time you said LOL and I took a picture and sent it to Kennedy.
Great. Thank you. Okay. Okay, let me finish. Getting h should be easy. You can plug back into here. And if you do a sign chart to solve for h, to get all the dimensions. And again, be careful when you do 2000 over 4 pi, you can reduce this 500 over pi, or do 2000 divided by parentheses 4 pi, then cube root. Domain for the radius is still from 0 to infinity because it's open interval. If you do a sign chart, 5 and 6, it'll be negative then positive. If you were to work it out, it would go from negative to positive, so it'll still represent local min. Yeah, I do like 5 and 6. If you plug it back into, 1 and 6, whatever. Yeah, 1's actually probably easier to try. So. Okay, so that covers. I'll put the homework up on our agenda later this afternoon. I don't think anyone's going to do homework on Friday afternoon. So. It's a nice day.